Good morning. So I did make these slides and then forgot to give them to you the other day. So let's look at them. Remember here, that's an NFA up there, a non-deterministic machine, because when you read a zero, if you're in this state and you read a zero, you either could go this way or go this way. And just as a reminder, non-deterministic finite automata, we say that it accepts string alpha if there exists a path from the accept state to, from the start state to an accept state labeled with that alpha, right? So you could have a lot of different paths. You could go straight here, or you could zip around for a while and then go straight, and you could zip around, right? There's choices here. And some of those paths, right, so alpha could have many paths that it follows, right? And if one of these is an accept state and the others are reject states, then we say that alpha is accepted. And if they're all reject states, then we say alpha is rejected. Right? So here's an example of a path, I guess. Right? There could be many, even if it's being accepted, there could be many rejecting paths. Right? So there's a rejecting path. And so so then we want to say, what's the language of strings accepted by this? And you might remember it's the strings that contain 0, 1, 0, 1. Right? The intuition is, how do you get over to the accept state? Well, you have to, at some point, have to do a 0, 1, 0, 1. Right? So our claim is alpha, that in this case omega contains this substring. All right, so we're going to definitely have a lot of questions in which I give you a language like this and you give me a machine. Probably harder, we could go the other direction. I give you a machine and you tell me the language. But then something that's explicitly written in the course curriculum, objectives, goals, the things that I'm supposed to teach you. There's, what are they? Learning outcomes, that's what we call them. A learning outcome is to formally prove that this machine accepts this language. All right? And I know as soon as people say formal proofs, then people get scared. And in general, the way I do formal proofs is, well, in general, there's a balance between how sort of casual in English, big picture you want to be versus how detailed you want to be about things. And my thinking is not to follow that logic course, but to do, there's some concept that we're trying to teach, and I tend to be anal about you getting that concept right, and then more casual about the details within that. All right, so in this case, what do you have to know? That if you want to prove that this NFA accepts this language, anybody want to guess what? There are two things you have to prove. Any ideas? You have to prove that if, I don't know why we switched from omegas to alphas, but that's just the nature of the beast here. You prove if a string is in the language, then what has to happen? Yes, exactly. Then there has to be an accept path, right? Now there's a second thing we have to prove. And people, when they prove these, students tend to prove this one and not prove the other one. What do you think the other one is? You have to prove if it's not in the language, then there's not an accept path. Right? Does that make sense? I mean, it's easy to make a machine that just accepts everything, and then if it's in the language, there's an accept path. Right? But we also need the converse, that if it's not in the language, then there's not an accept path. All right? So another way of saying that is all paths labeled alpha are rejecting. Right? So now we're going to prove the first part. And we're going to go various steps. And really, we can just sort of be logical through this. Right? Tell me the first step in a proof is to say, well, if alpha is in the language, then we just copy down here the definition. Right? What does it mean for alpha to be in the language? Well, it means that it contains 0, 1, 0, 1. Right? But here, I kind of moved ahead a little bit further and wrote it down in a way that was going to help us with the proof. I said, well, alpha has the form, it has some garbage, and then it has 0, 1, 0, and then it has some more garbage. Right? Everybody buy that? And now, anybody want to tell me how we're going to come from this to saying there's an accept path? Right? One way to prove that there exists something, how do you prove that something exists? You give it. Right, so give me a path labeled by alpha from the start state to the accept state. Yeah, what's the path? For the garbage, what it does, it just spins here, right? For the 0, 1, 0, what does it do? It goes across here. And for the garbage, what does it do? It spins here. Right? Everybody buys that? So what's our path? Our path is just what I said. Everybody buy that? So that's a proof of the one direction. Now, let's think about the proof in the other direction. We're trying to say, if it's not in the language, so it doesn't contain 0, 1, 0, 1, then there's not a path, right? And it's kind of harder to prove there's not a path, right? How do you prove there's not a path? To prove there is a path, what you have to do is you have to give me a path, right? To prove there's not a path, that's harder. Everybody buy that? So what are we going to do? It came up on the screen real fast. What are we going to do instead? We're going to go backwards. Remember, I had to check on Wikipedia to make sure that was the right word. Contrapositive. If A implies B, then if B is not true, A must not be true. Because if A was true, then B would be true, and B is not true. Everybody remember this? So we're going to take the contrapositive of this. What's the B? The B is there's no accepting path. So the complement of that is there is an accepting path, right? So here we're just going backwards. We're saying there is an accepting path labeled alpha. Hence, alpha is in the language, right? So we can go do the proof kind of just the same as we did it before. We have to make sure that the arrows go in the other direction, right? We have to say, hey, if there's an accepting path, well, if there's there's only one kind of path. It spins here for a while, it does this, and it spins here for a while, right? So let's call what it does here garbage 1 and what it does here garbage 2, right? And then what's the string we have that we're labeling? It is that, and hence it's in the language, right? Everybody buy that? And So you have to give both directions on a test. Now, one way of doing that I don't know if I think I didn't make, I was debating whether to tell you this or not. One way of having a proof like this is you say this, if and only if this, if and only if this, if and only if this, right? But if you're gonna do that, then you have to really make sure that your if and only ifs go in both directions, right? And if you write it, sometimes it's when you're coming up with a proof as you go, it's easier to write it twice to make sure that you've gotten the directions in both directions, right? Everybody with this?